Rate law shows us the mathematical relationship of reaction rate and the concentration of either reactants and products. There are many factors can affect the reaction rate. Here are some of them. The reactivity of the reactants, for example, nitrogen is relatively inert without a catalyst at high temperature. It is completely inert to hydrogen. No ammonia is formed. The concentrations are important. The more reactant available, the faster the reaction. The temperature is the key for most reactions. Usually, high temperature speeds the reaction rate up, and the catalyst, it changes the reaction mechanism, saves the energy consumed in the reaction, and accelerates the reaction. How to define the reaction rate? IUPAC recommends the definition of rate of reaction is shown here. We are free to express the reaction rate by either the consumption of reactant or the formation of product. The two expressions are equivalent, depends on you. The key in the rate expression is the concentration change within time change. If the time change is large, the rate is called average rate. If the time change is very small, even close to zero, then we call the rate instantaneous reaction rate. Generally, we have an universal expression of reaction rate. For a reaction, A reacts with B and others to give X and others. The rate is written as K times A with the power of n times B to the m, and etc. Where K is the rate constant or rate coefficient. N, M, P are the orders of the reaction with respect to substance A, B, and others. What we have to know is the rate law for a reaction must be determined experimentally. All the parameters K, N, M, etc. must be derived from the experiments. The orders of the reaction are not equal to the coefficients in the balanced chemical equation. For example, n equals 1, it means with respect to substance A, the reaction order is 1. We say it's first order reaction. With respect to A, when n is 0, we call it 0th order reaction. N is 0.6, it's a 0.6th order reaction. And even n is minus 1. We call it a negative first order reaction. How can we determine these parameters experimentally? We have to do lots of experiments, collect all the data, especially the initial rate of the reaction. Then we may use the power law directly to obtain the values of the parameters, or we may use the expression in logarithm instead. However, it's usually difficult to measure the initial rate in experiments. And more important, if there are intermediates of products were included in the true rate law, the rate law obtained will be wrong completely.